is Kevin, and today we're talking about chemistry. Okay, so you watched all our new videos about chemistry, bugs. Well, do you get bored of that biology and chemistry? And this is also the periodic table part 3. Have you watched the periodic table part 1 and 2 first? To know more about bonding and the particular overall of the periodic table, then please watch the periodic table part 1 and 2 first. And to know more about the Lewis-Dot diagram we're talking with today, then you should watch the periodic table part 2. Okay, now shall we begin? Let's start. First, you know, an atom is something that makes up molecules. And molecules we can write as the Lewis-Dot diagram, as I said in the periodic table part 2, which is an element's chemical abbreviation for its name in the middle, and the valence electrons around. So that is the Lewis-Dot diagram. Yeah, it could easily show how the electrons bond between two atoms, but that is 2D, so it doesn't show the molecular geometry of the molecule. So the prediction of it, which is the valence shell electron pair repulsion theory, Vsepr theory, could show the 3D versions, and it could tell the molecular geometry of the molecule easily. Scientists predict these in 5 common shapes. No, these are hard shapes. Okay? First is a linear shape, which means it shapes like a line. The next is a trigonal planar, which is shaped like a Mercedes, kind of like symbol. And the next one is a tetrahedral. And do you know how I could picture you this? It looks like a slice of Swiss cheese. Yeah, just like that. And it looks like a pyramid, but doesn't have 4 corners at the bottom. It only has 3 corners at the bottom. The next one is trigonal bipyramidal, which is shaped just like a tetrahedral pyramid, but it is 2 ones connected together. So that also means that you could fit 6 atoms in this. And the final one, which is also the one that it's the hardest to draw, is the octahedral shape. Here, you could look closely. This is the linear shape. Trigonal planar, tetrahedral, trigonal bipyramidal, and the final one, octahedral. You could see there are so many lines and dots. It took me 5 minutes to draw this. And the next one we're talking about is polar versus nonpolar bonds. Polar and nonpolar. These are characteristics in all the bonds, including covalent, ionic, and metal bonds. But today we're talking about only covalent and ionic bonds. So polar and nonpolar, these are 2 characteristics that divide it. So we could easily tell its melting point, boiling point, and other characteristics. So first, what is a polar bond? A polar bond is a type of molecule that creates a bond. But so the electrons are shared, but they're not, but kind of like they could be found more on one side than the other. All ionic bonds are polar bonds. And covalent bonds can be polar bonds or nonpolar bonds. A nonpolar bond is the opposite, which means the electrons are still shared, but they are equally divided because the electronegativity of the two atoms are equal. And the opposite is non-equal. So first, we will have a fun fact question. We have 3 questions on the way. First, we're talking about nonpolar bonds. So how could you tell if an atom is a nonpolar bond or a polar bond? You could look at the electronegativity of each bond, of each atom. I mean each element. So first, you have a bigger number and a small number, so you subtract the bigger number with a small number. And when you get the answer, which is less than 0.5, then it is a nonpolar bond. And if the electronegativity difference is arranged from 0.5 to 1.7, then it is a polar bond. So like CO2, it is a nonpolar bond between carbon and oxygen. So first, that carbon dioxide means 1 carbon atom and 2 oxygen atoms. So do you know that actually this molecule is nonpolar, but the bonds are polar? Well, that's a true fact, which is quite strange actually. And when carbon connects with oxygen, it makes a polar molecule. If you say, because it is more than 0, so you just think that they need to be same so they could be nonpolar. But their electronegativity difference is 0.4, so there are a nonpolar atom, a nonpolar molecule actually. So what do you think about this video? The fun facts, the polar and nonpolar bonds, the molecules, and the shapes. What do you think about this chemistry and geometry video? Well, if you like it, then please subscribe and like for our video. And you can see our latest new videos in my channel. Goodbye!